Welcome to another episode of the Pharmaceutical Calculations Solve Along. In this video, I'm going to show you a straightforward and easy way to solve normality calculation questions. Now, actually, this video was inspired by one of the questions that was asked on our last live session. So I'm going to go ahead and solve this question, but to add value to this video, I actually added two more questions, and these questions are going to provide additional perspective when it comes to normality calculations. So let's get right to it. Now the question says, calculate the normality of 0.321 grams of sodium carbonate when it is mixed in a 250 milliliter solution. So before I get actually into the true solution, I'm going to take us through a number of relevant equations that we need to have stenciled in our mind or be familiar with, and then we'll go ahead and solve this question. So the first thing is, what exactly is normality? When you talk about normality is actually equal to the number of gram equivalents of solute per liter of solution. All right, the number of gram equivalents of solute per liter of solution. So the question that immediately comes to mind is, how do you actually find the number of grams or number of gram equivalents of solute? So the way we do that is number, I'm just going to use the symbol. So number of grams, number of gram equivalents of the solute is actually equal to the weight of solute in grams divided by the gram equivalent weight of the solute. So your number, which is the term in the numerator here, this is how you find it. It's the weight in grams divided by the gram equivalent weight of solute. So then the question is, what exactly then is the gram equivalent weight of solute? Because that's important to know. So the gram equivalent weight of the solute is actually equal to the molecular weight. I'm going to use the symbol molecular weight of solute divided by the valence of the solute. So the valence for an acid will be the number of protons that it can actually give, right? So the valence helps you know the ability of the element to go into reaction, how much protons it has available, or how much hydroxides it has available if it's a base. All right. So these two equations, let's call this equation 1, equation 2, and equation 3. You have to go through steps 2 and 3 to get the value that goes in equation 1 here, and then you can solve for your normality. However, what you can actually do is simply substitute the expressions in equation 2 and 3 into equation 1 and end up with a rather nice and nifty equation which you can use more readily. So let's just say the normality is going to be equal to the weight of solute in grams. So we are combining equations 1 and 2. We are substituting those values into equation 1. And then we can multiply this by the valence. All of that divided by the molecular weight, just going to use the symbol MW, of solute times the volume of solution in liters. So this equation is very powerful, and you can simply substitute all your terms in there and you end up with your normality. So that's going to be at the heart of how we will solve most of the questions. However, I need to mention that sometimes in the question you'll be given mole information directly, so mole of a solute directly. And what we can then do is we can modify this equation and come up with another one where you have your normality is equal to the moles of solute times valence divided by the volume of solution. And that is because when you take the weight of solute and divide that by the molecular weight of the solute, you get the moles of solute. Then in some instances, you may be given molarity information directly in the question, in which case the easier and more expeditious one to use will be normality is equal to molarity times valence. And the reason that is possible is because your number of moles or your moles of solute divided by volume of solution in liters gives you molarity. So these three equations, you just pick and choose which one is more convenient for you based on the information in the question, and you can easily solve any type of molarity type question. So now that I've given this overview and background, let's actually go ahead and solve this particular question. And we'll be using this equation right here to solve this question. Now, by the way, if you are watching this live, you can go ahead and put your questions in the chat, and when I'll see them and address them for you. And if you happen to be watching the replay, then just go ahead and leave your questions in the comments, and I will address them as soon as I see them. So let's go ahead and solve the question, okay? So calculate the normality of 0.32 grams of sodium carbonate when it is mixed in a 250 milliliter solution. So the first thing we'll do is we'll make use of the equation that your normality is actually equal to the weight of solute times the valence divided by the molecular weight of solute times the volume of solution in liters. So from the equation, we already have the weight of solute, which is the 0.321 grams. We have some volume information, but that's in milliliters, so we need to convert the milliliters to liters. We'll do that a little bit down the line. But we need the molecular weight and we need the valence. So the molecular weight of sodium carbonate is actually 105.989 gram per mole. So now we have that information. And then when we talk about valence, what you have is you have sodium carbonate. And if you allow this to dissociate in an aqueous environment, you end up with 2 sodium cations and a carbonate anion. And the valence for this compound is the absolute of either the charge on the anion, which would be absolute of -2, which is 2, or the absolute of the charge on the cation, which would be 2 times 1, which is +2. The absolute of that is still 2, so the valence is 2. So we have the valence, we have the molecular weight. Let's address the volume of solution. So for volume of solution, from the question is 250 milliliters, but we need that in liters. So 1,000 milliliters is 1 liter. So that cancels out, and you end up with 0.25 liters. So right now we have all the information that we need to go into the equation, this equation. So for the normality, it's going to be equal to 0.321 times the valence, which we found to be 2, divided by molecular weight, which is 105.989, times the volume in liters, which we found to be 0.25. So when you go ahead and do the math, you end up with 0.024 normal. So that's the answer to the question, and that's how you address it. Now, I went a little bit slowly because I wanted to make sure that we are following each step. But once you know what you're doing, you simply need this equation, and you can plug and chug. And I know most students like just to plug and chug. You plug the information into the equation and just spit out the answer, okay? But that's the answer to this particular question. So whoever asked that question in the last live stream, just check this out, and this will be the solution to that question for you. Let's go ahead and look at another question. I felt that we can expand this whole learning experience to a whole nother level by looking at 2 questions that have similar type of concept, but the questions are framed slightly differently. So it's going to expose us to the different ways in which you can be asked normality type questions. So here, the question says, calculate the normality of a 3.5% weight by volume sodium hydroxide solution. Okay, so when we talk about normality, same thing, we're going to use that same equation. Your normality is equal to the weight of solute times the valence divided by the molecular weight of solute times the volume of solution in liters. Now notice that the weight of solute is in grams and the weight of the volume of the solution is in liters. So from the equation, we need information on molecular weight and valence. So let's go ahead and address those. Now the molecular weight of sodium hydroxide is actually giving us 39.997 gram per mole, or approximately 40 grams per mole. And the valence, when you take sodium hydroxide and it dissociates in an aqueous environment, you have a sodium cation and a hydroxide anion. And so the valence is actually the absolute of either the charge on the cation, so absolute of +1 will be 1, or the charge on the anion, so absolute of -1 is also 1. Hence your valence for sodium hydroxide is 1. Now we have the molecular weight, we have the valence. What we actually need is information on the weight and the volume. So we are not given an explicit weight like we were given in the previous equation, in the previous question, but here what we've been given is a concentration. So we want to recall our understanding from percentage concentrations. Now, if you need a thorough video on that, I have one video on percentage concentrations. I'll put a link to that in the description, and I'll also link it up in the cards. But when you talk about 3.5%, you're talking about 3.5 grams of sodium hydroxide in 100 milliliters. Now, notice we need grams per liter. So we need to determine how many grams will be present in a liter, and 1 liter is 1,000 milliliters. So we can solve for x. X is going to be equal to 3.5 grams times 1,000 milliliters divided by 100 milliliters, and you end up with 35 grams. So this implies that you have 35 grams in 1 liter. Okay. So what we can do now is we can substitute all of this information back into the original equation, which is this equation right here, and our normality is going to be equal to weight of solute in grams per liter. So that will be this information, 35 grams times the valence, which is 1, divided by the molecular weight, which is 39.997, times the volume, which is 1 liter. And so when you go ahead and do the math, we end up with essentially 0.875 normal. So the important distinction between this question and the previous one is the fact that in this question you were given concentration and we're not given quantity in grams and volume in liters or milliliters. So we had to make use of our understanding of percentage concentrations to bring some insight into what would be the quantity of the weight in grams to volume in liters. Okay, so a slight variation, but an important one. All right, so let's take a look at the last question, and that would give us some additional perspective on how we deal with normality type questions. And this question actually says, calculate the volume in liters of a 0.5 normal solution that can be prepared from 20 grams of phosphoric acid. All right, shout out to Philip, who is actually watching live. Thank you, Philip. Philip is one of our active members of the community, so I'm glad you could join us live, Philip. But right back to the question, it says calculate the volume in liters of 0.5 normal solution that can be prepared from 20 grams of phosphoric acid. So same thing, we want to go ahead and start with the equation, and this equation should be stenciled on your mind. So for normality, we're going to make use of that equation which says normality is equal to the weight of solute, that's in grams, times the valence divided by the molecular weight of solute times the volume of solution in liters. So this time around, what we're actually looking for is this term right here. We've been given the normality, the quantity, and we want to find the volume of solution. So the one term that we need, or we need two more terms. We need the molecular weight of solute and the valence. So the molecular weight of phosphoric acid is actually equal to 97.994 gram per mole, or approximately 98. And the next thing that we need is the valence here. So valence for phosphoric acid of H3PO4, if you allow that to dissociate in an aqueous environment, is going to be 3 protons plus PO4 3 minus. Now once again, the valence is the absolute of either the charge on the anion, so absolute value of -3 is 3, or the charge on the cation, absolute charge on the cation, so that'll be 3 times +1, so 3 times +1 is 3, and the absolute of that is also 3. So the valence for the compound is 3. So now we have all the information we need to put it back into the original equation here. And so what we'll have is normality is 0.5. So 0.5 is going to be equal to 20 grams times the valence, which is 3, divided by the molecular weight, which is 97.994, times the volume of solution, and we can use the variable y so that we can solve for y, and that will be our volume of solution. So if we go ahead and solve for y is going to be equal to 20 times 3 divided by 97.994 times 0.5, and our volume in liters is actually going to be equal to 1.22 liters. So we've gone through 3 very strategically selected examples on normality, and the conclusion is the best way to solve these type of questions is to use this equation or the molarity equation. All right, so I'm just going to go back to the first slide. And we started off with the original premise, but there are 3 equations that we ended up arriving at. All throughout, we used this particular version of the equation. We ended up using this version of the equation, and so what we want to do is be familiar with, depending on how your question is actually framed, you're either going to be using this version or the molarity version. Okay, but if it so happens that you have information on moles of solute, then you can also go ahead and use this version of the equation. So these 3 you probably want to have stenciled in your mind, and it's basically derived from each other, right? So you just need to memorize one, and then you can decide on how to use the others. So I'm going to stop here. I don't see any questions in the chat box at this point in time. Okay, I don't see any questions in the chat box. So I'm going to stop here, and if you have questions later on, just leave them in the comment section and I'll address them as soon as I see them. So thank you once again for watching, and I'll see you in the next video.